Okay, guys, so continuing on with these notes, today we're only doing two sections, 1.4 and 1.5. So 1.4, we're going to focus on the carbon cycle. So we're going to be looking at what we call sinks, sources, reservoirs, and how that carbon is going to move throughout those different areas. So our brief overlook here that we've got, we're going to be looking at the steps and reservoir interactions. We're going to understand that the carbon cycle is the movement of atoms between sources and sinks, that there are reservoirs where carbon compounds occur that hold those compounds for long periods of time, and that some only hold them for short periods of time. You're going to understand how carbon cycles between photosynthesis and cellular respiration, and how plant and animal decomposition have led to the storage of carbon through fossil fuels or sedimentary rock. And that when we burn those fossil fuels, we're moving that carbon back into the atmosphere in the form of carbon dioxide. For your practice FRQ today, you're going to explain relationships between different characteristics of environmental concepts, processes, or models that are represented visually. So that's a really big thing in APES, is to be able to see these diagrams, visuals, and then explain them. So some big things that we're going to be looking at are the movement of molecules that contain carbon, like carbon dioxide, glucose, and methane. So that's CH4 is methane, between those sources and sinks. Understand that some steps are very quick, like fossil fuel combustion, and some are very slow, like sedimentation and burial. So when we look at this diagram, it seems very complex, but it's really not, okay? But what I want you understanding is that when we have these things that happen quickly and we have these things that happen slowly, that leads to an imbalance. So in where the carbon is and how quickly it's moving from one reservoir to another. So atmosphere is a key carbon reservoir. It holds a lot of carbon, which is a good thing, but understand that those increasing levels of carbon in the atmosphere is leading to global warming. So a carbon sink is just any reservoir that's going to hold more carbon than it releases. An example there would be the ocean, so algae and sediments. What's going to happen to them is they're going to fall to the bottom. Then they're going to be compacted over time to create those sedimentary rocks, or those, sorry, I need to move myself. There we go. Those sedimentary rocks or those fossil fuels. Carbon is also held in plants, in their materials, like their bark, their leaves, their roots. And then the soil also holds carbon from when organisms die and are decomposing. And then we have carbon sources. So those are going to add carbon to the atmosphere. So our examples there would be fossil fuel combustion, animal agriculture from cows, really, okay, is the big one. It's not just cows, but cows contribute the most. So when they burp and when they fart, they release a lot of methane. And then deforestation, that's going to release carbon dioxide from trees, okay? So when we look at this diagram over here, a few things I want to point out. When we look at step number 3, it says some carbon can be buried, okay? So when we have those dead things, whether it's on land or whether it's in the ocean, when we have them dying, they get compacted over time. They get squished down by either the water or other layers of rock, things like that, and they get buried, and they turn over time into either sedimentary rock or fossil fuels. So those are going to take thousands of millions of years for that to happen. So that carbon is kind of stuck where it is. But when we look at step 4, we have human extraction of fossil fuels. So we're actually going down, we're taking those fossil fuels like oil, natural gas, coal, and we're burning them. And when we burn them, that's going to release carbon dioxide. Now, this happens a lot faster than 3 happens. So what we see is an imbalance in the carbon dioxide. We're seeing more getting released than being stored, which is going to lead to that climate change that we talked about. When we talk about these sinks and these sources, it's important to understand that sinks are going to help mitigate the impacts of climate change because they're going to be taking that carbon out of the atmosphere, and that carbon sources are going to speed up or increase the impacts of global warming because they're adding that carbon to the atmosphere. With our deforestation, that's a really big one because trees can act as a sink if we leave them alone. They take carbon in to do photosynthesis, and their impact kind of grows as they grow. As they get bigger, they take in more carbon, they hold more carbon. So when we start cutting those trees down, we start releasing a lot of that carbon that they could have been holding. So deforestation becomes a source. The trees themselves are a sink. All right, photosynthesis and cellular respiration. It's important that you understand that cellular respiration is not just us breathing. A lot of people think, oh, respiration, it's breathing. It is not. They are two completely different things, okay? But these work together to form a very quick loop of carbon entering and exiting the atmosphere. So our photosynthesis, we hopefully know, is going to be being done by things like plants, algae, phytoplankton. It's going to take carbon dioxide from the atmosphere and it's going to turn it into glucose, which is a carbon-containing molecule. The formula for that glucose is right there, C6H12O6. And then that glucose is going to store energy in the form of sugar. So photosynthesis would be considered the carbon dioxide sink because it's taking carbon dioxide from the atmosphere. And then we come to our cellular respiration. So that's done by plants and animals. I know a lot of times you hear that cellular respiration is just animals. It's not. Plants also go through cellular respiration. And that's going to release that energy that's stored in those glucose molecules. So it takes oxygen from the atmosphere and uses that to break down that glucose and to release the energy that's being stored there. But as a byproduct of that, carbon dioxide is created, which gets released back into the atmosphere. So cellular respiration would be considered a carbon dioxide source because it adds carbon to the atmosphere. But like I said, this is short term. This happens quick, okay? So like that sedimentation that we talked about, that's a long period of time. But photosynthesis and cellular respiration happen very quickly. And they happen at about equal rates. So you can see when you look at these formulas, in photosynthesis, we have 6 carbon dioxide going in to photosynthesis. And when you look at your respiration formula, you have 6 carbon dioxide coming out. So they really balance each other out. So ocean and the atmosphere, those are 2 big players in the carbon cycle. So we have what we call direct exchange, and that's where that carbon dioxide in the atmosphere is going to move directly into the ocean, and the carbon dioxide in the ocean is going to dissolve out and back into the atmosphere. This also happens very quickly, and it happens in equal directions, so it balances the amount of carbon dioxide between the atmosphere and the ocean. So we have no net increase, just like in photosynthesis and cellular respiration, no net increase in the carbon. So that's when we look at the diagram over here, that's being represented by number 5. Okay, so it's being dissolved, and you can see it's got an arrow going both directions because some is released and some is dissolved both ways. So because of that direct exchange, when we have more carbon dioxide in the atmosphere, that's going to lead to more carbon dioxide in the ocean, which leads to ocean acidification, which has pretty severe consequences for the organisms that live in the ocean, because as that happens, the pH of the water is lowering. And as we know, everything is suited to live in a specific environment. So if we continue to decrease the pH of the ocean water, we're going to start seeing impacts on the plants and animals that live in the ocean. When we talk about the ocean, algae and phytoplankton, they're considered to be a sink. They take carbon out of the ocean and out of the atmosphere through photosynthesis. And that's being shown right there in your diagram. Another thing that takes some carbon out of the ocean would be the coral reef and any marine organism that has a shell, like crabs, things like that, because they create an exoskeleton that's made out of calcium carbonate. So they use that carbon to create their exoskeleton. So when we talk about sedimentation, which is really important when we talk about the ocean, what we see there is marine organisms die, their bodies sink down to the bottom, okay, and they get broken down into sediments that contain carbon. So over time, what we see is that compaction happening. So they're going to get squished and squished and squished and squished, and they're going to form those sedimentary rocks or those fossil fuels. And then with burial, that's where we're going to actually see those turning into the sedimentary rock or the fossil fuels. Sedimentation is just when they're getting broken down into the sediments. So they get broken down during sedimentation, and then during burial, the sediments get squished together to form the rock, like limestone or sandstone, or the fossil fuels. And this is considered a long-term carbon reservoir because this takes thousands, millions of years for those rocks or those fossil fuels to be created. So like I just said, it's very slow, stores carbon in underground sinks. So sediments get compressed either by overlying rock pressure or the layers of water. They're just heavy, so they just push them down. Understand that fossil fuels, when we talk about those, we're talking about things like coal, oil, natural gas, which are formed from fossilized remains of ancient organisms. So our two examples here, coal is made out of dead ferns typically, and marine algae and plankton are what's going to create the oil that we're using. So when we look at our diagram here, we're really going to be focusing kind of on this extraction and combustion. So that's digging up and mining the fossil fuels and then burning them. And that's going to release that carbon into the atmosphere. So when we look at our diagram here, we can see we've got our decaying organic matter. And over time, we're going to form things like coal, oil, sedimentary rocks from those decaying organic things. And then we're going to drill down into those things and remove them to burn them for our use, okay? And we call that combustion. Now, this is a really good form of energy for us. It's very efficient. It gives us a lot of energy from just a little bit of material, but it releases lots of carbon dioxide, which causes an imbalance because we're releasing more than we're storing. And that's what I just said. Okay, let me move this out of the way. So it takes longer than extraction and combustion, so there's an increase in carbon dioxide in the atmosphere. All right, and then your practice FRQ for today, identify one process in the diagram that happens quickly and one process that happens slowly. And then I want you to explain how the rate at which fossil fuels are transferred into the atmosphere, as shown in the diagram, has altered the carbon cycle during the past 250 years. Whoa, my light went out. Hold on. There we go. So for that one, I want you to think about some kind of process that's changed over the past 250 years, and how that's going to affect the amount of carbon dioxide in the atmosphere and therefore the climate.